the topic of electric current and the model questions which are coming in this topic. Okay. Now, main electric current we are having mainly three important we have. One is about the current, another one it is about the potential difference or the voltage, current, voltage and resistance. Okay. Mainly three we have, the current, voltage and resistance, that is. Current actually it is nothing but the rate of flow of charge we are taking. There is nothing but the rate of flow of charge. That only we call that as current, where current I is equal to Q by T, that is. I is equal to Q by T, rate of flow of charge. And if you see the units, sometimes they are asking the question about units also here. So, actually here for the case of units, for the charge it is of coulombs we have and time it is of second. So, coulomb per second it is the unit for the current. That coulomb per second it is also called ampere, that is. Okay. Coulomb per second is equal to ampere, that is. Means 1 ampere of current means if 1 coulomb of charge passes through any of the conducting there for 1 second, then we can say the current passing there is 1 ampere. So, means again see that 1 ampere of current is nothing but 1 coulomb of charge is passed through a wire for 1 second, then we can say the current passed there is of 1 ampere, that is like this. So, which means from this you can know that 1 coulomb of charge, if you want, you can also write that as 1 ampere second, that is. Okay. So, like this, depending on the units also, sometimes they are asking the questions about how the units of current varies with. Actually, current we can write coulomb per second, or we can also write that as coulomb per second, it is of ampere, that is. Next one, come to the case of voltage, and here the voltage it is nothing but also called as the potential difference, that is. Okay, which is called potential difference. Potential difference. Okay. When come to the case of this potential difference, which is represented with V, okay, it is nothing but the work done by the battery here, or the power source you are taking, or the electrical energy you are taking. So, the work done by the electrical energy on the unit charge, that only we call that as V, that is. Okay. Now, actually V is equal to, it is nothing but the work done on unit charge, that is, which is V is equal to W by Q, that is. From this you can also write W is equal to VQ, that is. Okay. Actually voltage, if you are taking its units are, as the work done it is about joules we have, and whereas Q it is of seconds we have. Joule per second, sorry, joule per coulomb we have, where Q it is of charge, that is. So, joule per coulomb, that it is the unit of voltage here. Okay, that is of voltage, its units are joule per coulomb. 1 joule per coulomb, we call that as 1 volt. If you are doing 1 joule of work on a unit charge here having the charge 1 coulomb, then we can say here the work done is equal to 1 volt, that is. The potential difference becomes 1 volt, that is. So, here even for the case of this voltage also we are having two different units. One is joule per coulomb, or another one is volt. Joule per coulomb or volt, both are same here. Okay. From this also you can write 1 joule is equal to 1 volt per coulomb, that is. Or you can also write here like this as 1 joule per coulomb, 1 joule per coulomb is equal to 1 volt, that is. Or 1 joule is equal to, from this, 1 volt coulomb, that is. Okay. Like this, depending on the given case, here we are having the different units for this voltage. In terms of work we can write joule per coulomb, or in terms of directly the voltage we can write. Okay. And the third one we are having the resistance is present, and the resistance actually its units are ohms we have. Okay, because according to that Ohm's law we are having as V is equal to IR is there, as V is equal to IR. For the case of resistance we are taking resistance. Okay. In case of resistance if we are taking, we are having as V is equal to IR there, where V is we are having voltage, I means the current, and R means the resistance here. From this we can write R is equal to V by I, that is, where V is that is of voltage and I that is of ampere, that is volt per ampere. This you call that as resistance, that is. So, that resistance only we are represent with ohm. Okay, it is also called ohm. Even about the units also here, about the current units, about the voltage units, about the resistance units they are asking. Okay, and when come to the case of the resistance, we seen we are having volt per ampere, or we can also write that as ohms, that is. Here current, voltage and resistance here, which is volt per ampere, which is for ohm. For the case of voltage, we are having joule per coulomb or volt. Like this, depending on the unit given there, we have to change our units. Most of the cases they will give on the case of units based on for current, voltage and resistance. If you see how we are getting the different values is, so that unit of voltage is coulomb second given there. Now we will see the different questions on units about how they are asking in the exam. Okay, about the units of the three different cases, we are having the voltage unit there, current unit there and the resistance unit is there. In the first question given that unit of voltage is in the option A given, that is of coulomb second, option B given joule per ampere, and third one given joule per ohm, and option D given coulomb per second and ohm, that is. Like this, actually we are having different units are there. This one it is given in terms of coulombs and seconds, this one given joule and amperes, which is work done and the current, and joule per resistance, which is work done and resistance they give, and coulomb second and ampere, that ohms is given there. So, like that, depending on the given one, we have to change our unit here. Actual voltage, its units are as voltage V is equal to, it is of W by Q, that is. If you are writing in terms of joules, which is V is equal to W by Q, joule per coulomb, that is. So, actually any of the case if you see, we do not have that joule per coulomb is there. Okay. So, in the first case it is given that is in terms of coulombs and seconds, that is given. As V is equal to W by Q, then it is equal to joule per coulomb, we are having that. And option B given, that is given joule per ampere, that is. Actually C meant for coulomb, that is. So, means it is not joule per ampere. Whereas joule per ampere means we are taking work done on unit current we are taking, that is, but that is wrong. So, joule per coulomb we do not have that. And next one you will see coulomb per second, it is given there. Coulomb it is of the charge there and second it is of the time, that is. So, that is why it is not coulomb second also. And if you are taking in terms of resistance here as V is equal to IR, if you are taking as here the ohms is given there, then we can write here in terms of V, that is of W by Q, which is J by C, you can write here is equal to IR, that is, where J by C its units, it is equal to current, it is of amperes, that is, and resistance, that is of ohms, that is. Then if you want to write voltage in terms of joules and ohms, that is, then we have to write in place of that J by C, which is volt, it becomes ampere ohm, that is. But here it is given that is of joule per ohm, that is. So, which is that also a wrong one, that is. So, you cannot take this one also, and already coulomb per second is wrong. So, only here that coulomb per second to the ampere is correct, because as voltage V is equal to ampere ohm, that is, which is like IR if you are taking V is equal to ampere, it is of Q by T, that is of coulomb per second, that is, which is the current, that is. Ampere, that is current, whereas current I is equal to Q by T, that is. Then it becomes C by S ohm, that is. So, that is why here in this case the voltage unit it is of this one is correct, which is coulomb per second, which is represented as current here, and whereas ohm that is about resistance. So, here the voltage formula we are taking as V is equal to IR. From that we can conclude that C by S ohm, that is the unit of the voltage here. Then if you come to the case of second one, which is about the current, the unit of current is given that C by S ohm, joule per second, volt per ampere, that is volt per ohm, that is, and volt ohm given there. So, this time we are taking for the case of current I. As we know that V is equal to IR, here I is equal to, from this you can write V by R, that is. As the current I is equal to V by R, in the first case that is given C by S to the ohm, whereas coulomb per second if you are taking coulomb per second, which is Q by T, this is the ampere here. So, but actually here the current unit is ampere, but it is given C/S ohm, that is, which means ampere ohm is given, which is the wrong one. So, coulomb per second per ohm, that is not a correct answer, that is a wrong one. And the next one, if you are taking B, joule per second. Joule per second means that is like joule, it is of work done, and by time, which is W by T, which is about power, that is the unit of power, but not in the case of current. So, that is why even joule per second is also the wrong one. And when come to the case of C given that is volt per resistance is given. As V is equal to IR, then I is equal to V by R we have. So, that the voltage actually we represent with V, that is, and the resistance actually that is represent with ohm, that is. Then here for the case of current, we can write instead of ampere, we can also write that as voltage per ohm, that is. So, that is why here option C is correct, whereas volt and ampere is wrong, that is of volt ohm is wrong. Here volt per ohm only correct, because from V is equal to IR, we got I is equal to V by R, that is where V is the voltage and the resistance we are having ohms are there. So, that is why V by ohm is correct. Now, come to the third case, the unit of resistance if you are taking, that question given it is of ampere coulomb there, coulomb second there, joule per second there, joule per coulomb ampere is given there. Again resistance if you are taking as V is equal to IR, then from this you can write R is equal to V by I, that is. From this you can write R is equal to V by I. Then R is equal to V by I, where V is the voltage and I is the current here. So, in any of these cases, as no voltage is given, we cannot write the equation R not in terms of V and I, that is. Okay. So, then from this we can write R is equal to, for the voltage V and the current is, that is of Q by C, that is. Whereas current is nothing but coulomb per second, that is of coulomb per second. Okay. In the first case that is given ampere coulomb, ampere that is of current, coulomb it is of Q, that is, okay, which is I into Q, which is not the unit of resistance, that is. So, ampere coulomb is wrong one. And next one if we take, that is of coulomb second is given there. Again coulomb, that is about the charge, which is Q into time. Q into T is not about any of the current here, that is also coulomb per second is also wrong one, that is. Next one we are having joule per second is there. Joule per second, which is again work by time, second it is of time, that is work by time, that is for power we have. So, that is why even this one also wrong one, that is. Now, when come to the D option, joule per coulomb ampere, that is. Whereas joule we are taking, that is for the case of work done, and coulomb that is the case of Q, and ampere that is about the current we are taking. W by Q actually this is nothing but called as voltage, that is. Then we can write in place of W by Q as V, then by A, that gives you R. So, that is why R is equal to that ampere, A is nothing but equal to I, that is. So, that is why V by I is equal to R, that is. So, as R is equal to V by I, then the units are going to be D is equal to, that is of J coulomb ampere is the correct answer. Like this, depending on the units they are giving, we have to check which unit is correct for the given physical quantity. For the case of voltage, for the case of current, for the case of resistance. The next case about other than the units, how the questions are coming from the voltage, resistance and current is about the devices which are measuring the voltage, resistance and current. When come to the case of voltage here, actually to measure the voltage we prefer voltmeter, that is. The device which is used to measure the voltage is voltmeter, that is. Then when come to the case of resistance, which is nothing but volt by current, that is. Here for the case of resistance we use most of the cases multimeter we prefer. Whereas in case of current if you are measuring, then current is measured by using amperes, that is which is of ammeter we prefer. Okay. So, voltage actually we are taking that as voltmeter, and resistance in multimeter, and current we are using that for measuring that current we are using ammeter, that is. So, most of the cases the questions they are asking on this one is how you are connecting that voltmeter and ammeter here. Okay. We know that already that when you are taking the case of the voltage, whenever if you want to find the voltage across any battery or the voltage along any of the electronic appliances if you are taking, then if you arrange the resistance, if you are arranging that electric circuits here or electronic components there, if you are arranging them in parallel, then what happens there is the voltage remains the same. So, that is why whenever if you are taking any of the electronic appliances, if you want to find how much is the voltage is present or how much is the voltage drop at that electronic component is, for example, here if you are taking for the case of a bulb, if you want to find for this bulb how much is the voltage you have, then what we have to do is we have to connect this voltmeter. Voltmeter actually it is represented with this symbol V. Okay. Now, we have to connect this voltmeter parallel to the any of the electronic appliance there like this. See, the main uses of keeping this voltmeter arranged parallel to that electronic component is when you are taking parallel here, what happens there is the current divides, whereas the voltage remains same in both the cases. So, that is why the voltage drop at the bulb and the voltage drop at the voltmeter, as these two are connected in a parallel here, what happens there is here we can find how much is the voltage drop is present at the bulb here. Like this we can find the voltage for any voltage drop across any of the electronic component, that is when you are arranging the voltmeter in parallel to that. Now, when come to the case of this current, means how much is the current passing through any of the electronic component, if you want to find how much is the current passing, then we have to arrange this current which is of in series we have to arrange, because when you are taking the ammeter here, ammeter actually we are using that for measuring the current. The current actually if you are arranged that in a series here, in case of series always the same amount of current is passing through that. So, that is why if you arrange the ammeter in series, then what happens there is here whatever the current is passing through the bulb, the same amount of current it is passing through the resistance we have. So, that is why most of the cases this voltage if you want to use voltmeter we have to arrange that in parallel. If you want to use the ammeter, that ammeter we have to connect that in series, because in case of this parallel the voltage value remains the same, in case of series the current value remains same, that is. Okay. Now, in case of this resistance if you are taking the multimeter there, for the multimeter actually directly we are having two pins are connected. If you are taking the two pins directly connected to our electronic appliances, and directly it shows the how much is the resistance we are having for that bulb there. Like this, depending on the uses of different devices, actually we have to arrange them in parallel or in series according to the given electronic devices, that is. And here one more thing, if you want to increase or decrease the resistance, if you want to increase or decrease the resistance, the decrease or increasing means we want to change the resistance here, we use a separate one, we call that called rheostat, that is. The rheostat is nothing but which one it is used for measuring this, which is used to change the resistance here, rheostat, that is. The symbol for this rheostat is here like this it is. This arrow mark represents that is a varying resistance we have. Varying resistance means we can change the resistance value at that point by using that rheostat, that is. Then you already know that the current for the case of voltage, the symbol we are using is like this, voltage, and for the case of current we are using ampere, that is like this. These are the different symbols we are using for measuring any of the devices, that is. Now, we will see the relation to that voltage, resistance and current, which is about Ohm's law. They are asking the next questions on that, okay, which is about Ohm's law, that is. But remember, when you are applying this Ohm's law, main important thing we have to remember is a constant temperature. This Ohm's law is valid only when you are taking at the electronic appliances there, the temperature should be constant, that is at constant temperature. So, if you see the statement of Ohm's law there, it is given that at a constant temperature, whatever the current you drawn, that is directly proportional to the potential difference applied at its terminals. Means whatever the current you drawn I is directly proportional to how much is the potential difference we are applying there. So, more and more potential difference if you have, then more and more we can draw the current here. That is the meaning of Ohm's law, that is more voltage, more current, less in voltage, less in current we have. From this only we can write as I, taking out that proportion, we are having a proportionality constant is coming. That constant only we call that as conductivity, that is, which is the reciprocal of resistivity, that is, or reciprocal of the resistance, that is, okay, of which K is equal to 1 by R. From this we can write V is equal to IR, that is, V is equal to IR. Okay. So, this is about Ohm's law, that is, Ohm's law statement is at a constant temperature. Here we are having the amount of current you are drawing from the for the electronic appliance is directly proportional to how much is the potential difference drop we have, or the potential drop we have at that electric circuit, the electric component, that is. Okay. Now, the main number of questions asking about this is about its limitations they are asking. One of the important limitation of this Ohm's law, it is maintained at a constant temperature, that is. And another important one is this Ohm's law is valid only if you are taking about a metallic conductors, that is, if you are taking any of the metallic conductor only, here it valid, that is, which is I directly proportional to V. But you are using a semiconductor devices like we use in case of these chips here in our computer systems there. For those cases like germanium you can take, silicon you can take. For those cases of semiconductors, we cannot apply this electric current, we cannot apply this Ohm's law, that is. Okay, and not only that, when you are using these LED bulbs, light emitting diodes there, in those cases also we cannot apply this Ohm's law, that is. Okay. And another important one is when you are drawing a graph between the voltage and the current, as both are directly proportional to each other. Here the question they are asking is what is the shape of the graph if you draw a graph between the voltage and the current, here like this. For voltage and current, if you draw a graph here between voltage and current values, as both are directly proportional to each other linearly here, then what happens there is we are getting a straight line which is passing through origin, we are getting, which are passing through origin. And now for example, actually this is for the case of Ohm's law we are taking, only for ohmic conductors we are taking. Ohmic conductors are the conductors of which that Ohm's law is valid, those we call that as ohmic conductors. If it is a non-ohmic conductor, if you are taking non-ohmic conductor means which are not valid this Ohm's law, which are not taking this Ohm's law format, that is of we are taking the LED bulbs you can take, or the semiconductors devices you can take, or some other if you are taking here, what happens here for varying temperature cases you can take. If the temperature varies, what happens there is the resistance may change. So, that is why here Ohm's law is valid only if you are taking about a constant temperature there. If the temperature is not same, or if you are taking a non-ohmic substances there, then that V and I graphs we are getting like a curve we are getting. For example, in this case we are getting a curve like this. Okay, like this means when you are applying the voltage difference there, the current variation is not same. Sometimes it is increasing, sometimes we are having more increment is present, particularly for the case of semiconductor devices. Okay, like this, sometimes they are asking about the graphs from Ohm's law, that is between the voltage and the current. When you are taking the voltage and current, if it is a ohmic conductor, here we are having a straight line is coming. If you are taking for the case of semiconductor devices like germanium or silicon, if you are taking, we are getting a curve like this. So, that there is an increase in the voltage there, gradually there is an increase in the current is also coming there. Okay. Like this, we are having different limitations are present for our Ohm's law. So, most of the questions MCQs they are asking about the limitations of Ohm's law here. And the next one we are having about that relation to voltage, resistance and current. In that, important one is about resistance we have. Okay. Now, we are discussing about the importance of this resistance first. At first, if you see the definition of resistance, resistance is nothing but when you are taking any of that current carrying wire here, inside that wire we are having the movement of electrons are there which are moving with their drift velocities. When they are going across any of these wires here, inside that wire we are having a lattice is present, where lattice is nothing but the arrangement of positive charges we have, that we already know. that is of the arrangement of these positive charges present inside that wire, we call that as lattice. Whenever these free moving electrons, if they passed over that lattice, what happens there is a decrease in the speed of the current, decrease in the speed of the charges we have. That only nothing but the strength of the current gradually decreases, which means there is opposing of current takes place, opposing of the flow of charge takes place. That opposing the flow of charge only we call that as resistance here. So, based on this resistance, we are having the number of questions are coming when it is connected in parallel and when connected in series. Total 2 cases we have, resistance in series case and resistance in parallel case we have. Resistance in series case means if you are arranging all the resistance in the series here, whatever the electronic appliance you took, electronic components you took, or the resistance you are taking here in case of series, let us suppose R1, R2 and R3 if you are taking, if these 3 are connected in series connection means nothing but applying side by side, we are connecting all the 3 resistance. Then what happens there is, here the current passing through them is the same we have, because these resistance mainly it depends on 3 factors here. One is about the temperature that you already know, which the factors you are taking. One is about the temperature, and the next one it is about the length of the wire you are taking. Because on increasing the length here, then what happens there is more number of lattice are present there in the way of the charges there, so that more chances of obstructing these electrons we have. So, that is why when you are increasing gradually the length of that, then gradually what happens there is an increase in the resistance takes place. So, that is why the current flowing through that is less. So, that is why here this resistance depends on the temperature you are taking, at what temperature, and the length you are taking. If you are increasing more and more the temperature there, then what happens there is the resistance value also gradually increases. And in the same way, if you are increasing more and more length, that is, then what happens there is the resistance value again increases, that is. And the next one we are having about the thickness. This resistance of the wire depending on the thickness here or the area of cross section. More and more area of cross section if you are taking, then here the thickness of the wire is more, means here the resistance value becomes less. At the same time, as you are having the more number of, if the thickness is more, then we are having a chance of more number of electrons will pass through that. So, that what happens there is the thickness increases, then the conductivity of the current also increases, which means that in opposite way the resistance of the wire is decreasing here. Like that, we are having this resistance as it is depending on the temperature there, length there, and area there. We are having a formula getting there from that. By using that formula, R is directly proportional to the temperature there, to the length there, and area there. We are having a formula there, if you remember, R is equal to rho L by A we have. The resistance value R is equal to rho L by A, where rho means it is called as resistivity, L is called the length, and A is called the area or the thickness we are taking, area of cross section, that is. So, R is equal to rho L by A, that is. Okay. Now, if you see the case of series connection, as I said now, if you are taking the series resistance is 1 by 1 added, gradually the length is increasing. If the length increases, now only we discussed that if having more and more length is present, then the resistance value also gradually increases here. So, the resistance value is increasing, so that the conductivity of the current gradually decreases. And not only that, when you are taking the resistance in series, the current passing through each resistance will remain same. Another very important MCQ they are asking. When you are arranging the resistance in a series there, when you are arranging all the resistors in series, then what about the current? The current actually here, the passing through them remains same. Whatever the current it is passing through R1, the same current will passes through R2, and the same current will passes through R3, that is, which means here I1 is equal to I2 is equal to I3, that is. Okay. And not only that, when you are taking for the case of the voltage, the potential drop here, if you are arranging that resistance in terms of a series, that is, then what happens there is, as the current remains the same, as V is equal to IR for different resistance, and we are having the same current, the potential value will be different here, which means here we are having a different voltage, let it be that is V1, and here we are having a different voltage, let it be that is V2, and here we are having a different voltage, let it be that is V3 that is. So, depending on the resistance here, we are having a different voltages present. And how much is that voltage related is, we know that as V is equal to IR, means V is directly proportional to I if you are taking the resistance constant, or if you are taking the current, in this case constant we are taking, as the current remains constant, then V is directly proportional to R here, which means that more and more R value if you are having, then the voltage drop at that point is also required is more we have, then only it can pass the same amount of current in all the three resistance. For example, if you are taking R1, R2, R3 values there, so that if you are taken R1 is greater than R2, greater than R3 if you are taking, then how the voltage drop also depends is, as R1 is we are having more voltage is there, then what happens there is the voltage drop at that point also more, and V2 value also more, and V3 value also more there. Depending on the resistance we are having the voltage is present, as V and R both are directly proportional to each other. If R1 is having the maximum resistance, then voltage drop at that point also be maximum we have. Like this, in MCQs sometimes they are asking about how the resistance values changes with respect to the voltage drops here. So, depending on the resistance we are having in the given circuit there, depending on that only we are having the different voltage drop is present if we are taking that resistance in series that is. So, as in the case of series, now we will see that the current remains the same there, I1 equal to I2 equal to I3, and voltage and resistance both are directly proportional to each other we have. So, that is why in case of series connection here, gradually on increasing the number of resistance you are adding in series, gradually the total resistance also increases. So, that is why here you will get, for the case of series connection, RS if you are taking, then RS is equal to R1 plus R2 plus R3 that is. Which means if you are adding more and more number of resistance there, gradually the total resistance value also gradually increases if you are arranging all these resistance in terms of series that is. For example, if you are using for all the cases the same type of resistors here, R1 is equal to R2 equal to R3 equal to and so on, then what happens there is the final resistance becomes, for example, up to n resistance if you are using, then RS becomes, RS is equal to R1 plus R2 plus R3, which means R plus R and so on n times we are taking, which means finally we are getting, as we are taking n number of resistors are there, then it becomes RS value becomes NR that is. Like the final resistance becomes the equivalent resistance if you are arranging R there, each resistance having R, if you are adding that for number of times n number of times there, then the final resistance becomes n into R that is. So, from this it is very clear that when you are arranging the resistance in terms of series, mainly 3 points we have. One is the current is not changing, the current remains the same, and depending on the resistance here, the voltage drop is different we have. So, means if the resistance it is taken in series, current remains same, but voltage is changing. And how that is changing means, as the resistance increases, voltage drop also increases that is. And another important third one we are seeing that if you are having the more number of resistance are added in series here, gradually equivalent resistance also increases, because if the length increases, as the resistance value also increases. So, that is why the final value RS is equal to we got, if you are arranging RS is equal to R1 plus R2 plus R3 we are taking. In a special case, if you are taking all are of having the same amount of resistance is present, R and R if you are taking, then we are getting RS value is R plus n number of times if you add that, then we are getting RS is equal to NR that is. Like this we can use in case of series connection the different questions they are asking. Now, if you see the applications of resistance if you are taking, the how the questions they are asking is where we are using this, particularly this is series connection wire there. Here the problem with that resistance here we have is the current passing through here is of same. So, means whatever the current passing through that resistance 1, we are having the same current is passing through R2 and the same thing it is passing through R3 also. So, that what happens there is, as the same current here passing through that, if you off one of the light, then what happens there is the remaining also becoming off here. That is the major problem in case of this resistance connection there. When you are arranging all that in case of a series connection, if you cut one of that, then the remaining also will be connecting off only, that is. So, that is why most of the cases these resistance in series, we observe that when you are taking the bulbs which are connected in series, in case of decoration bulbs you will see. In case of these decoration bulbs, all that we are having the same amount of current is passing through that. So, that what happens there is, here if you off one of the light here, the remaining also will be off. Like that we use in case of this series connection, that is the obligation of a series connection we have. Now, we will see now of which the series this resistance you are taking, we are having mainly 3 factors it depends there. We seen that is of a temperature there, we have seen that it depends on the length of the wire you are taking, and we are having that area of cross section we have, which is of a thickness we have. Let us say for example, in the exam they will ask the questions like this. If you are having 3 copper wires are there having the length 10 centimeters, 12 centimeters and 15 centimeters if you are taking, then of the 3 cases 10 centimeters, 12 centimeters and 15 centimeters, of these 3 which is having less resistance is present, we have to find. Means less resistance means in which case we are having more amount of current will pass there. But according to our case here, we know that resistance is directly proportional to the length. Of the given one 10, 12 and 15 centimeters, that 15 we are having more in length we have. As the resistance, the length is more, here the resistance value will be maximum here. Here for the case of 15 centimeters, we are having maximum resistance is there. If the resistance is maximum, then the passes of current will be minimum in that case. So, that is why answer is not 15 centimeters. The one which is having less resistance, it passes more current here. Of the given one, we are having the 10 centimeters, we are having a minimum is there. So, that is why the resistance in that case is minimum, because the length of the wire is less in that case. So, that is why here we are having less current of less amount of resistance is present. So, that what happens there is more current passes through that. So, that is why most of the cases if you see, when you are taking any of the connections there, you can take a bulb, you can take a fan, you can take any of the electronic appliance there. From the main switch here, the length required there to connect to that, we always prefer the minimum length, that is. Because if you are increasing the wire length there, gradually what happens there is a increase in the resistance takes place. Then if the resistance is increasing, then the passes of current will be less. So, that if you want to get the more current here, then we have to arrange the more potential difference there, because if the resistance is increasing means the potential difference across that point also required is more we have. Like that, depending on the resistance you are arranging in series, we are having different factors are present. Then in the same way, if you are using more and more thick wire there, for example, if you are using a thick wire of 2 mm wire in case of 1 mm and in case of 5 mm wire there. So, that what happens there of these 3, the one which is having less thickness is present, which is for the case of 1 mm thickness wire if you are taking, then what happens there is, as the thickness is less, here we are having more resistance is present, because as more resistance is present, then the passes of current will be less in that part. Whereas, if you are taking for the case of 5 mm wire there, of which it is having more thickness is present, as the thickness is more, then what happens there is the resistance value is less, that is. As the resistance value is less, so that the current passing through that will be more. So, that is why when choosing a current here, when choosing a wire here, if you want to pass more amount of current, then we have to always prefer more thick wire, just like we see in case of AC or any of the refrigerators you see, we are having the wire should be taken as more thickness having. Having more thickness means increase in the current is also more, whereas the resistance there acting is less we have. And whenever if you want less amount of current here, there we have to take the more in length, that is, if you are having more in length, the resistance value gradually more there, so that the passes of current is less. So, the conductivity of current is less in case of if you are taking more length, that is. So, depending on the length and depending on the area here, the resistance values changes. Now, we will see resistance in series we already seen. Now, we are taking the resistance in parallel case. Resistance in parallel, that is. When you are taking the resistance in terms of a parallel here, then what happens there is, here parallel connection means each resistance is connected one on another, that is like this we are taking. Okay. Then in this case what happens there is, as you are taking all are one on another, the voltage remains the same at any of the resistance you are taking. Here the voltage, here the voltage, here the voltage, and here the voltage. In all the four cases, the resistance values with R1, R2, R3 and R4 if you take. In the case of this parallel connection, the voltage remains the same, which is V1 is equal to V2 equal to V3 equal to V4, that is like this. But whereas if you are taking the resistance values are different, as the resistance values are different here, the current passing through each resistance will be varied here. So means here when you come to the case of this R1, here different current, here I2, here I3, here I4. Then here in this case the current is different, and how that current varies with the resistance here is, as we know that again as V is equal to IR, then here the voltage remains constant in all the cases, then the current varying is inversely proportional to the resistance here, because as V is constant, then I is inversely proportional to R. Then more and more resistance if you are taking, then the current passing through that will be less you are taking. For example, of the given 4, if R1 is having more resistance, then the value of current passing through that I1 value is less. If R4 is having very less resistance if we have, then the current passing through that will be more we have. So that's why on increasing the resistance here, R1 greater than R2 greater than R3 greater than R4 if we are taking, then the current values will be reverse we are getting, of which I1 is less than, I2 less than, I3 less than, I4 we have. So that's why on increasing the more number of resistance here, then the current value gradually decreases. But in this case of parallel connection here, we are having the voltage drop is same. As the current divides here, then the main important application in this one is, if you off any one of the resistor here, one of the electronic appliance here, then there is no problem to the other, because gradually if you observe here at every junction point here the current is divided, so that when you are removing this R1 there, R1 resistor if you are removing that, then nothing will happen, then it directly the current passes through R2, R3 and R4. No problem to the connection of R2, R3 and R4 there. Like that, in case of this parallel connection, we are having number of applications are there. For example, in our household, if we are taking the domestic circuits there, most of the cases all these domestic circuits we are having connected in a parallel only. So that's why we can operate separately the each electronic appliance, that is, let us say for example, if you want to use only bulb there or only fan there or only TV there, then if you want to arrange, if you want to run that different way, that here individually separately if you want to arrange, so that if you off one, the other one also we have to work there. So that's why in those type of circuits we need a parallel connection like this. But here as you are taking the resistance is more, the current carrying there is less. If you are having the less resistance is present, then the current carrying it is more. Then if you are arranging like this, the reference resistance in terms of parallel, then the equivalent resistance becomes 1 by R is equal to, when connected in parallel, it is equal to 1 by R1, 1 by R2 plus 1 by R3 plus 1 by R4. Because here the current is varying here depending on the resistance. Then finally we got the equivalent resistance, RP value becomes 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Always remember the equivalent resistance when you are using this series connection here, when you are using this parallel connection, the final equivalent resistance is the least value when compared to the remaining individual values of the resistance. Okay? So very important one. If you are using any of the resistance there in terms of a parallel, if you are using whatever the equivalent resistance final value you are getting, its value is less than the individual values you are taking there. Okay. So that's why here as 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. If suppose if you are taking all the 4 resistance are having the same value there, R1, R2, R3, R4, all we are taking the same, like this, you are connecting n number of resistors are present, then how the equivalent resistance becomes is 1 by Rp is equal to 1 by R, 1 by R, 1 by R, like that we are adding n number of resistors, that is. Then finally it becomes 1 by Rp is equal to n times of 1 by R, which means n by R, that is. As this is reciprocal you are taking, then Rp value becomes R by n. Here only you can observe that here the final resistance we are dividing that by n number of resistors here. How many number of resistors we are taking, that each resistor it is divided with the number, that is. So, which means that the final equivalent resistance we are getting is less than the individual value. So, how many number of whites you are taking, how many number of resistors you are taking, that many times the each individual resistance is decreasing. This is the case of a parallel. So, that is why as the parallel connection here, if you observe, as the equivalent resistance is decreasing, then the current carrying more actually increases. So, that is why if we are connecting the wires in parallel, always there is a more passes of current takes place. If you are arranging the wires in terms of a series, like increasing the length there, then what happens there is the resistance value increases and the length gradually increases. So, the passes of current decreases, that is. But once if you are arranging like this parallel, one on another each wire, the thickness gradually increases instead of length. As the thickness is gradually increasing, so that the passes of current is also gradually increasing, so that the resistance value here it is gradually decreasing. So, like this, depending on the usage of our domestic circuits, we are using sometimes the series connection, sometimes we are using for the case of parallel connection, that is. Okay. So, always remember, in case of series connection, if you are arranging, the final equivalent resistance will be more, and whereas in case of this parallel connection, if you are taking, the value of the equivalent resistance is less than the previous connections, that is less than the each individual resistance. So, that is about resistance we have. N resistors, if you are taking, given question is, if n resistors, each resistance is smaller or joined in series and then in parallel. So, first case they are using that in terms of series, that is, and the second time they are using that in parallel, that is. Then the question is, we have to find the ratio to the series connection or equivalent resistance to the parallel connection, resistance connection, that is. See, as n resistors if they are taking, and we are taking the resistance in series if you are taking, then final Rs value it becomes, we have to arrange directly that R1 plus R2 plus R3 we have to take, as Rs is equal to, according to our formula, R1 plus R2 plus R3 plus and so on, so that it becomes here R plus R plus R plus R we have to take for n number of times. Like this, n times we are taking. Then finally it becomes, as we are adding these resistance R for n times, then the final resistance becomes n R, that is. And in the same way, if you are taking for the case of a parallel connection, that is Rp value, then if you are taking for the case of Rp, then the resistance, equivalent resistance 1 by Rp is equal to, then according to our formula, 1 by Rp is equal to 1 by R1, 1 by R2, 1 by R3 and so on, up to n times we are taking that. As we are adding that n times here, but each one it is having a resistance of R only here. So, 1 by R, 1 by R, 1 by R and so on, n times we are taking. Then 1 by Rp value becomes, as we are adding that 1 by R for n number of times, then it becomes n of 1 by R, that is. Okay. Then it becomes n of 1 by R means n by R, that is. Then finally, the Rp value becomes Rp is equal to R by n, that is. Now, we got the Rs value which is n R, that is, whereas Rp value we are getting R by n, that is. Rs means the resistance when connected in series, and Rp means the resistance when connected in case of parallel connection, that is. Now, the question is, it is about finding the ratio between Rs and Rp values, that is. Here we are taking Rs value and Rp value. Whereas Rs we got that as n into R, whereas we are getting that Rp value as R by n, that is. Then it becomes finally resistance in series to the resistance of parallel is equal to n into R by R of that n come to the numerator, that is. That RR get cancelled and finally we got Rs by Rp is equal to n into n, which becomes n square, that is. So, Rs by Rp is equal to n square we got, which gives you the relation that the resistance series is equal to n square times the Rp square, that is. Okay. Rs is equal to n square times Rp we have, where n is the number of resistance we are taking. From this it is very clear that the resistance if you are arranging in series, it is always more than the resistance when you are connected in parallel. But in this case, if you are taking the equal number of resistance there, from this it is very clear that Rs is equal to n square times the Rp value. Or if you want to find n value, then easily we can find from this n is equal to square root of whatever the equivalent resistance we are getting for series and whatever the equivalent resistance we are getting the parallel, and the root if you are taking, then we can get how many number of resistance are used. Like this, depending on the given condition, whether it is in series or whether it is in parallel, we can find the different cases of resistance here. So, as the uniform wire of resistance 50 ohms is cut into 10 equal parts, then which means we have to take that 50 and each one 10, that is 50 by 10, it becomes each one we are having the resistance of 5 ohms we are getting. As 50 ohms is equally distributed to all the 10, then we are getting each one of 5 there. So, this each one 5, first it is arranged in series, later again it is arranged in parallel is given, that is. Okay. So, means first if you are taking for the case of a series connection, as 5 are arranged in series, then R1 plus, R2 plus, R3 plus, R4 plus, R5. And in all the cases, all the 5 cases, we are having the same resistance, that is, which is 5 plus 5 plus 5 plus 5, of which we are having now 5 resistance which we are connected here, of which total it becomes 25 ohms, that is. This is when you are arranging them in case of series connection, that is. Whereas, if you are arranging them in terms of a parallel, that is, then and again the same 5 we are taking, and we have, if the resistance is connected in parallel Rp, we know that 1 by Rp is equal to 1 by R1, 1 by R2, 1 by R3, 1 by R4 plus 1 by R5, that is. And each one we are having the resistance there of 5, that is. Then it becomes 1 by Rp value is R1 is 5, R2 is 5, R3 is 5 and R4 also 5 and R5 is 5, that is. Like this, that 1 by 5 we are adding total for 5 times we have. So, that is why here 1 by Rp value becomes 5 times 1 by 5, that is, of which 1 by Rp value is 1. Therefore, we got finally Rs value we got that as 5 ohms, 25 ohms, and Rp value we are having 1 ohm we are getting, that is. Because that 1 by 5 we are adding that 5 into 1 by 5 it becomes 1, that is. Then Rp value it becomes 1 ohm, that is. Now, the finally what they are asking is what is the equivalent resistance when both are connected again in a series, that is. So, which means that Rs value we are getting and Rp value we are getting, these both are again arranged in series, that is. Then the final equivalent resistance becomes, as these two are again connected in a series. In series connection means directly we have to add both the resistance here. Then the final resistance becomes 1 by Rp, that is Rp plus Rs, that is. Whereas Rp value we got 1 ohm, Rs value we got 25 ohms, that is. Then finally it becomes 1 plus 25, it becomes total 26 ohms we are getting. So, like this we can find for the different cases of given the resistance there which is in series connection and the resistance another one which is in parallel, and that parallel one and this series one is again both are connected in series, then finally we got Rp plus Rs is equal to 26 ohm. The same thing you can do if you want, we can take that in a parallel connection also. Then if they are arranged after getting the final R and Rs and Rp values, if you are getting that final here, if you want to connect that in parallel connection, then how to do that is 1 by R is equal to then again 1 by 25 plus 1 we have to take. Then we are getting the value if they are connected in parallel. So, now see the next one which is of given total 4 resistance are there which are of 4 ohms, 12 ohms resistance, 14 ohms, 14 ohm resistance. This 12 ohms and 4 ohms, these two are connected in parallel, whereas this 14 and 14, these two are connected in parallel here. and again if you see these two are again connected in a series here. So, means two parallel and those final equivalent resistance both are arranged in series, that is. And here the given that the voltage we are using is 10 volts there, then what we have to find is the current in the circuit. Now, for these type of problems, at first we have to calculate that between 12 ohms and 4 ohms, these R12 of 12 ohms and 4 ohms which are connected in parallel, first we have to find the resistance equivalent for them. Let us suppose this resistance is R1, this is R2 and this is R3 and this is R4, that is. Okay. Then if you are taking R1 and R2 values there which are connected in a parallel here, then equivalent resistance becomes 1 by Rp is equal to 1 by R1 plus 1 by R2, that is. Then 1 by R1 which is of 1 by 12 plus 1 by 4, that is. This is 1 by Rp value, that is. Then how much that value becomes is 1 by Rp is equal to 12 and 4. If you are taking LCM there 12 which is 1 plus 4, that is. Okay. Of age 433, that is. Then finally it becomes 1 by Rp is equal to 4 by 12, that is. Means 1 by Rp value becomes 1 by 3, then Rp value here it is 3 ohms, that is. So, means when you are taking the connection, if they are connected both in parallel here with 4 ohms and 12 ohms, then final resistance we are getting is 3 ohms we are getting. Okay. And after that, if you are taking for the case of R3 and R4, if you are taking, then again these two are connected in parallel, that is. Then again 1 by Rp is equal to 1 by R1 plus 1 by R2. So, that it becomes 1 by 14 plus 1 by 14, that is. That is of 1 by Rp value. Then 1 by 14 which becomes 2 by 14, that is 1 by Rp value, whereas Rp value becomes again for the second case it is becoming 7 ohms, that is. Okay. Then here if you are taking that Rp value first case, that is of 3 ohms, and for the case of second case that becomes 7 ohms, that is. So, means the same circuit diagram we can also do that as by taking this R1 value, R2 value, we can substitute that as one circuit, that is having taking only 3 ohms, that is, because in the first case when they are arranged here we got only the 3 ohms resistance, whereas second case if you are taking, if R3 is 14 and R4 also 14 there, in that case if you arrange that parallel, again we are getting the resistance here 7 ohms. Then these two are connected in parallel to the battery there given, of which we are having 10 volts is given there. Then 3 plus 7 it becomes a total, as they are in series connection here, then final resistance becomes R is equal to 3 plus 7, that is, which is of 10 ohms, that is. Then the final resistance as it is becoming 10 ohms and the voltage supplied there it is of 10 volts we have. Then we got the resistance and we got the voltage, and we know that as V is equal to IR, then V voltage is equal to IR here. From this we can write I is equal to V by R, where that voltage it is of given 10 volts, whereas the resistance final equivalent resistance becomes 10 ohms, that is, which is of finally we are getting 1 ampere current. So, like this if you are taking any number of resistance or in series connection if you are taking, we can arrange them with a parallel, another one with a parallel, and we can arrange them again like a series, or like in the previous problem we seen, two are considered, that is of in parallel and one is in series, and that parallel, and again we are connecting in series connection. Like this we can do different number of problems they are asking by using these series connections and parallel connections.